Today we are learning about the prediction of central atom in hybridization. Before we proceed to our lesson, we recall that the types of hybridization consist into 5. They are SP as a linear, SP2 trigonal planar, SP3 tetrahedral, while SP3D trigonal bipyramidal, and for the last SP3D2, the shape is octahedral. For your information, all the types of hybridization here follow the basic shape of molecular geometry. Okay, next, the first thing we are focused into the first type of hybridization. This is sp hybridization. For your information, the hybridization prediction is judged for central atom. Hence, for the example, by using the molecular formula beryllium dichloride, explain or predict the hybridization and show the overlapping orbital of this molecule. Remember, follow the step. Our first step, step 1, you must draw the Lewis structure and its formal charge. Step 2, draw the specific shape of molecular geometry. And for the last, we try to predict the types of hybridization. Okay, now, we proceed to our first step. By using the molecular formula beryllium dichloride, we must draw our Lewis structure. So our central atom is beryllium, consists 2 valence electron, chlorine 7 valence electron times 2, and the overall electron is 4. And we draw our Lewis structure. Beryllium as your central atom covalently bond with the 2 chlorine atom, and these 2 bonding pair consist 4 electrons, and this is considered as the total up here is 16. So 16 minus 4, this is 12 electron, and the 12 electron here placed onto the terminal atom to ensure our terminal atom are octet. Okay. Next, we calculate the each formal charge for each atom. Formal charge is chlorine is 0, beryllium also 0, and another chlorine also 0. And the next step, by using the formula of molecular geometry, BeCl2 have the specific formula is AB2, and the molecular geometry can be formed as a linear. And we redraw the specific molecular geometry of beryllium chloride as a linear and the angle can be predicted is 180 degrees. Now, we are focused into the third step, prediction of types hybridization. So, our molecular geometry, we already find out BeCl2 in form of a linear molecular geometry. And the first step, by using the valence orbital diagram, you must write down your terminal atom first. And our terminal atom here is a chlorine atom. So, our chlorine atom has a proton number is a 17 and our electronic configuration should be 1s2, 2s2, 2p6, 3s2 and 3p5. So, therefore, we can find out the valence electronic configuration of field inside the 3s and 3p orbital. So, this is your next task. By using the valence orbital diagram of the terminal atom of the chlorine, we need to show in the 3s orbital and 3p orbital, we can determine chlorine have 7 valence electrons. So, from the 7 valence electron here, we can trace together the presence of one pair of electron and it's allocated at a 3p orbital. So, therefore, by using the molecular geometry, each chlorine atom have one unpair and this one unpair exists in 3p orbital. So, done already. And from the molecular geometry also, we need to find out together the unpair of the central atom beryllium and this orbital of the beryllium can overlap with the orbital chlorine to produce our first sigma. And another than that, second unpair for beryllium overlap with unpair for chlorine to produce for second sigma. Means for next step, we must to show valence orbital diagram for central atom. So, for information, this central atom can be proceed to the process of hybridization and element is beryllium. Next step, we need to write down valence orbital diagram for beryllium atom. So, we write down first step, beryllium ground state. For your information, beryllium element consists of 4 proton number and electronic configurations we have 1s2 and 2s2 and the 2 valence electron are filled inside the 2s orbital. So, in valence orbital diagram, we can draw it's only involve 2s orbital and we feel 2 electron filled together, but at the same time, at the period 2 also have empty p orbital. So, when we are transform the molecular geometry, beryllium must be require 1 unpair and 2 unpair because beryllium can be formed 2 sigma, so it require 2 unpair of electron. So what happened here, the pair in 2s orbital will excite into the empty p orbital and we can proceed to the next step we can call as a beryllium excited state. So, beryllium excited state here, we can trace 2s orbital and a 2p orbital, but differences of them here, we can find out 2s orbital only consists 1 electron and a 2p orbital also consists 1 electron. So, the presence of the two unpair in 2s and 2p orbital, we can trace here. One unpair is for first sigma and for the second unpair for the second sigma when the central atom overlapping with the terminal atom of a chlorine. So, our last step here, beryllium hybrid. So, our previous writing, we can trace beryllium at excited state consists 1 unpair and 2s and 1 unpair to 2p, and they will mix together to produce new hybrid orbital, and therefore finalize we can have 1 orbital involved in s and 1 orbital involved in p, and we label as a sp hybrid orbital. So the sp hybrid orbital, this is a linear. So from this linear, you must suppose writing in drawing. So we draw as a linear shape. Okay, and then you label it. Center is beryllium. So it's involved sp orbital. And for each orbital consists 1 unpair. And another orbital have 1 unpair. So next step, we can trace from the valence orbital diagram of a terminal atom, we can find 1 unpair exists in a 3p orbital, and this orbital will overlap with the sp orbital for the beryllium. So it's involved for the 2 atom for beryllium, and we label it. So our terminal atom is a chlorine, and we have unpair for chlorine overlap by n to n sigma bond form, similar for this part. Sigma bond and label the orbital is involved for 3p orbital. So therefore, the shape of the orbital here is linear and the types of hybrid is sp orbital. Now, how you explain the formation of sp hybrid orbital? So we focus on the central atom. So we can label beryllium atom form 2 sigma bond with chlorine atoms. Boron atom excite to form 2 orbital with 2 unpair of electron, which can form 2 sigma bond. Next, through the hybridization, beryllium form sp hybrid orbital, and each chlorine atom overlap through 3p orbital with sp orbital of beryllium atom to form 2 sigma bond.